Welcome to lesson 84, graph of functions. Okay, so let's get into it. All right, here's our objective, our vocabulary, some rules and notes for you. And okay, so let's look at our first example. In a city, a taxi costs $2 per mile. Okay, so when you see the word each, every, and per, this means division. The unit before per is y, and the one after it is your x. All right, so that's your rate of change because it has per each and every. $2 per mile has 2 units in it, plus a base fee of $1.75. Show the cost for 5 miles and graph the situation. Okay, so what does this mean? So that's the first thing we write in an equation. We're going to write y or f of x. Remember, y and f of x mean the same thing. Doesn't matter. All right, so what do we have? $2 is our rate. Our rate always multiplies to x, and then you add 175, your other term. So now, when they say show the cost for 5 miles, they want to include all terms. So which we need is a table of values. We need our x, 2x plus 1.75. And so when x is 0, 1, 2, 3, 4, and 5. So 2 times 0 plus 175 is 175. 2 times 1 plus 175 is 375. 2 times 2 plus 175 is 575. 2 times 3 is 6 plus 175 is 775. 2 times 4 is 8 plus 175 is 975. And 2 times 5 plus 175 becomes 1175. Now here's a little trick and a little shortcut. Our rate is 2. So if you take your base and just add 2 to it every time, you can see 1, 3, 5, 7, 9, 11. So that's a little shortcut when making a table of values. Okay. So we're picking up example 1 on this page, and we had 1, 2, 3, 4, 5. So we're at 175 at 0. 375, 575, 775, 975, and then 1175. Okay, so this graph right here is very tiny, so we're going to estimate. We're going to put in some numbers. I'm going to put 1, 2, 3, 4, 5. And then since these are close to 175s, we're going to put 2, 4, 6, 8, 10, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't have enough to go every 2. So I guess I could have started. You can start wherever you want, and you can make your numbers however you wanted to make them. So at 0, we're at 175, just under 2. At 1, we're at 375, just under 4. At 575, 775, 975, and 1175. And that's how we would graph it. You graph it using your table of values. Your x is always on the left, and your y or your f of x, they're the same thing, is always on the right, on a horizontal, on a vertical table of values. And then you just plot your points. Now these become points where the x is and the y. I guess I could have did like that, did a big giant parentheses. These are all points. A table of values give you points. And that concludes our first example. Okay, so let's look at our second example. Write a function rule from the table. Okay, so if we had to write a function rule from the table, what we need is the change. The change from here to here is 1, and the change from here to here is 1. So it's 1, it's changing by 1. So our change in f of x is 1, and our change, and that little triangle means change. It's capital Greek letter delta. It just means change. So it's 1 over 1. So our rate of change is 1, because 1 divided by 1 is 1. So what does that mean? F of x equals 1. The rate of change always multiplies to your variable. And then now we start at the starting point. When x is 0, the blue is our starting point. So we started at 2.5. And that's all it takes to write an equation from the table of values. You need your change, your rate of change, and where 0 is. And once you do that, you can write a rule, a function rule for any set of points on a table of values. Okay, so those were our two examples. Take a story, turn it into an equation, make a table of values and graph it. And the other one was to take a table of values and turn it into an equation. We should probably graph that one too, but I didn't. And as I think about that, I probably should have, since this is a graphing functions lesson. So pick up, do the examples, and I will meet you at the end of the video for a recap. Okay, so here we go. The first thing we're going to do is find the rate of change. So in x is changing by 3, by 3, by 3, and by 3. And then y is changing by 3. Oh, look at that. Okay, so our change in y, or our f of x, is 3 over our change in x, which is 3. 3 divided by 3 is 1. So our change is 1. And when x is 0, we will find our intercept. So f of x equals the rate of change, always multiplies to x, plus when x is 0, whatever number is when x is 0. So what do we have here? We have a situation right here. I only have positives. I don't have any negatives, so I'm only going to graph these 3 points. And all you need is 2 points to draw a straight line anyway. So let us do this. Since this is 0, I'm going to make every other line, well, I could make every third line 3, right? 1, 2, 3, 4, 5, 6. Let's see, I don't have 12 lines on Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since it doesn't always work out neatly, you can always change your axes. You can make the numbers and the lines anything you want on your axes. So if I use this spacing, I would only be able to plot 2 points, 0, 6, and 3, 9. And my line would look like this. I could shrink the things down. So let me show you another way of graphing. Something else I could do. I'm going to erase all this that I have. And let me show you what else I could do with this. Draw another graph on there. And show you another way to line up the axes. So when you have graph paper, you can do just about whatever you want. All right, so let's do this. Let us make every other line 3. So 1, 2, let's make that 3. 1, 2, 6, 1, 2, 9. Let's say 1, 2, let's make that 3. That's 6, 9. Okay. And then you do not have to go by the same numbers on each axis either. Like I could have did this every 1. I could have did 3 every 2. I could have did 3 every line. I could have did something different here. But sometimes if you make your points smaller, you get more points in. And you get a similar line. So you can always choose, but make sure it's consistent on each axis. So I did the same spacing on both axes, and it made it neat for me. But you can have different spacing on your axes. You just have to choose it and make it work for you. Okay, so graph the relation. So let's see what we're changing by 1, by 1, by 1, by 1. We're changing by 1 each time. Okay, so I don't have any positive points on here. So we're going to have to guess. So first thing we do is find the change in f of x, which is 1, the change in x, which is 1. 1 divided by 1 is 1. So our equation, f of x equals 1x. The rate of change always multiplies to your variable. And that's -3, so -3. And we're going to pretend these lines go all the way down. These lines go over. So on and so forth. Okay, so here we go. So -5, 4, 3, 2, 1. Here's 0, -1, -2, and I'm not making -3. -2 is at +1. So that's right there. Let me plot the point. Wait, oops, I made a wrong point here. So let me erase that point. Okay, so let's go back. All right, 0 is at -3. 0 is at 1, 2, 3. All right. 1 is at -1, -2. And then 2, -1. And you can see your line is going to go like that. Not quite exact. I should probably had a different graph here because I don't have any positive points. But you can see you're going to have to, make some extra lines for the negatives and make your own points, because these points just don't work with the graph that I chose. Okay, and let's look at our last one. Okay, so we're changing by 1 on x, and we're changing by 2 on f of x. Okay, so our change in f of x is 2. And we get that by subtracting. 2 minus 0, 4 minus 2, 6 minus 4, 8 minus 6. Our change in x is 1. 2 divided by 1 is 2. To write our equation, f of x is the rate of change, 2 times your variable, plus when x is 0, you're starting at 2. Okay, so here we go, 2x plus 2. So we're going to make each line 1, 1, 2, 3, because it's easier. 1, 2, 3, 4, 6, 7, 8. And so 0, 2, 0 starts at 2. 1 starts at 0. -1 starts at 0. So it'll be down here somewhere. And I'm just guessing based off the graph. 1 is at 4. Or maybe it's a little bit over. 2 is at 6. And then 3 is at 8. And so your line is going to come down through there. Just like that. So that is graphing. Hopefully you went to the geometry and watched the intro to geometry and the first lesson in geometry so that you understand how I plotted these points. If not, please go over to my geometry playlist. Look at lesson 3001 so that you can understand how we plot points and how these plots were pointed if you have any questions. So thank you for watching. I will hope that you will subscribe and like this channel, share it with other people, leave me a comment, and I will see you in the next video.